Hi guys, I welcome you all for the course Manipulated Robotics Theory course. So we are going to see some problems in inverse kinematics. Okay. So today we are going to discuss inverse kinematics numericals. In the last video, I said in order to get the inverse kinematics, you should know the forward kinematics. From this, we are going to find out the formulas for theta RD. So this is the concept, okay? So today we are going to see one problem for the RP manipulator. So for this, you should know the forward kinematics. So this forward kinematics we have already derived using DH matrix and DH formulation as well. So it is C10 S1 and S1D2 because it's RP manipulator. S1 means that is for revolute, D2 for prismatic joint. So here S1 0 minus C1 and me minus C1 D2, then 0 1 0 0 0 0 0 1. Okay, so this is the forward kinematics for the RP manipulator. And then your client, client will give you the goal or desired. T means it is a homogeneous transformation matrix. These three will give you the rotation matrix of the end effector or orientation of the end effector. Then these three will give you the translation or position of the end effector. Okay, this is the normal takeaway from this transformation matrix. So this is given by the client, okay, or the desired. So the desired is given to you. So 0.354 and 0.866 and 0.354, 0.106. This is for the first row. Second row is minus 0.612, then zero point 0.5 and minus 0.612 and minus 0.184. And then next one is 0.707, 0.707, then 0, then 0.707 and 0.212, then 0.0001. Okay, this is the desired transformation matrix given to you. Now what we have to do is we have to compare this and we have to get the formula for theta 1 and d2. So this is my goal. Okay, so what is my goal? Find theta 1 and d2. Okay, so let's find theta 1 first. So here, if you take these things, okay, these two, if you take the ratio, you will get theta 1. Okay, so we can go for cos inverse of this, but always go for tan, arc tan. So in robotics, we are going to use arc tan to arc tangent only. So we need to get only the tan of that particular values. So how will you get theta 1? If you take the ratio of S1 by C1. So here what is S1? Minus 0.612. So how do I get theta 1? Theta 1 equal to S1 by C1. And then this S1 corresponds to minus 0.612. And then C1 corresponds to 0.354. Okay. So this is tan theta 1. Okay. So what is theta 1 from this? Theta 1 equal to arc tan 2 of, what is the sign value? Minus 0.612 comma 354. Okay, this way. Or you can do in this way also. Okay, in this you have to cancel this and you can get this, or you can take this term also. Okay. So here we have three methods. So you just in your calculator take tan inverse of minus 0.612 and then here come up divided by minus 0.354. So you can use the calculator, undo it, and then the angle will be 60 degree. theta 1 will be 60 degree if you apply the formula. Okay. So did you understand this? So here what we are going to do is either you can take this combination or this combination or this combination. Okay. But whatever it is, take the ratio of it. Okay. So if you take the ratio of it, then you will get the theta 1 as 60 degrees. So we found theta 1. Now we are going to find out d2. Okay. So for d2, you have to take these terms. Okay. So these terms. So let's take. Okay. So in the next slide. So generally, they are transformation matrix. Okay, the 2 to 0 general term. I mean R11, R12, R13, R14 like that. R21, R22, R23 general representation. R31, R32, R33, R34, R41, R42, R43, R44. Okay. So this is general representation. So when you relate that in the previous slide, we have seen this term is S1 D2 and then this term is minus C1 D2. Okay. So how I'm going to get D2 is I'm going to square R1 4 square plus R2 4 square and then I'm going to take the square root. Okay. So that you will get D2. Okay. So here in this, or the simple thing is if you square this, what is the answer? S1 square, D2 square. Plus, if you square this, it becomes C1 square, D2 square. So what is the answer? You will get D2 square. Okay. So D2 means square root of. So that is why D2 equal to plus or minus square root of this one and this one. Okay. So let's substitute. And then in the problem, it has given plus or minus R14 is 0.106 square and then R24 is minus 0.194 the whole square. Okay. So square it, add it and take the square root. Your answer will be plus or minus 0.212. That's all. So using this forward kinematics, we found the formula for D2 and theta 2. Okay. So the theta 1 is tan of sine by cos. Okay. And then d2 is this one square root of this square plus this square. So this is called as the solution, or this is called as the numerical solutions for RP manipulator. Okay, so let's see RPY manipulator. So next one is RPY manipulator. So RPY means it's the third degree. So 3 degree of freedom T30. It is given like this C1, C2, C3. So this you should have calculated using DH matrix. So C1, C2, S3 minus S1, C3, C1, C2, and then RP manipulator. There is no translation. It is 0 only because it's a wrist. So in this, there is no translation. So S1, C2, C3 plus C1, S3 minus S1, C2, S3 plus C1, C3, S1, S2, 0 minus C2, S2, C3, S2, S3, and C2, 0, 0, 0, 0, 1. Okay. Okay, so now let's derive the formula. So here there is no translation, only orientation of the wrist. Okay, so that is under RPY moment. Okay, so now let's derive the formula for this. So in this equation, so this is S2 and this is S3. Okay, if you take these two, okay, so so this one is R31. Okay, so your R31 is minus S2 C3. Okay, and R32 is S2, S3. Okay. So if you divide R31 by S2, you will get minus C3. Yes. Here, if you divide R32 by S2, you will get S3. Okay. Or I can say your tan theta 3. Tan theta 3 equal to arc tan 2 of what is S3? R32 by S2, comma, what is C3 minus R31 by S2. That's all. This is the formula for. So if any values or desired values are given, so just locate this R32 and because see here S2, so if you divide this, S2 will be cancelled. Just take the value. So R32 and the minus R31, take the ratio and take tan inverse, then that will be your theta 3. Okay. So we found the value for theta 3, number 1. Okay. Then how will you find for theta 2? Okay. So theta 2. So let's use this one. Okay. So here theta 2. So for that first you get theta 1. So for how do you get theta 1? So let's use this. So tan theta 1 equal to arc tan 2 of tan 2 of. So let's take this. So this term is in terms of R1, R21, R22, R23. Okay. So R23 by S2, comma. Then here you have C1, so it is S2 again. So R13 by S2. So this is your theta 1. So in this way, if you divide R23 by S2 means you will get S1. If you divide R13 by S2 means you will get C1. So sine by cos is tan. So tan theta 1. So in the desired formula, what you have to do is, so you have to pick this term and take the ratio and get the tan inverse. So you will get theta 1. So theta 1 is done now. Okay. So this is my second. Okay. So now theta 2, sorry, theta 1 is here, theta 3 is here. So now we have to find theta 2. Okay. So how will you get theta 2? So you can take these ratios. So theta 2 is, so I'll write here, tan theta 2 equal to, so sine term we want. So what is this actually? This is R23. So R23 by S1. Okay, R23 by S1 means you will have S2. And then here this term is R3. That's all. Okay, so you have to take arc tan 2 off. Okay, so let's write again. So what is theta 2? I mean tan theta 2 equal to A arc tan 2 of, what is this term? R23 divided by S1 and then R33. Okay. So this is the third equation. This is how you have to derive the values. Derive the values or derive the equations for theta 1, theta 2, theta 3 from this. Okay. So we'll do this with one example. So here the matrix is given. So the matrix is this T goal. T goal is 0.1496, 0.527, 0.8365, this is 0, minus 0.6558, 6558, minus 0.580, 0.48290. Then this one is 0.7399, minus 0.620, 0.258800, then 001. Okay. So let me take the formula. So what is the formula for theta 1? We have already given the formula, that is, so it is arc tan 2 of theta 1 means we have to take down these values. So here minus 0.4829, comma 0.8365. So use the calculator, take tan inverse of this by this. So you will get theta 1 is 30 degree. Okay. This is theta 1. And then theta 3 is these two terms, theta 3. Okay. So theta 3 equal to arc tan 2 of minus 0.620 and then 0.7399. Okay. Then if you solve this, you will get 40 degree. Okay. can solve this using the calculator. Okay, so now this term is C2. Either you can divide by the S1 and this, or simple thing is your C2 cos theta 2 is from the formula, it is 0.2588. Okay, so you can get S2 also, you know this formula 1 minus C2 square. So 1 minus C2 square is around 0.9659. Okay, so your theta 1 is, sorry, it is theta 2. Theta 2 is A tan 2 of sinus 0.9659, comma 0.2588. If you solve this, you will get 75 degree. Theta 2 equal to 75 degree. Okay. So this is how you have to derive the equation. I mean, find out, I mean, you have to find out the equation for theta 1 and theta 2, and you can solve it using the numericals. Okay. And one more problem, let's see RRP manipulator. So next one is RRP manipulator. Okay. So in this, the formula is, I mean, T30. Okay, T30 is C1, C2 minus S1 minus C1, S2, then minus C1, S2, D3. This is the OM matrix derived from DH formulation. And then this is C1 minus S1, S2 minus S1, S2, D3. And here S2, 0, C2, and C2, D3, 0, 0, 0, 1. Okay. Yes. Now the goal is given, or desired value is given by the um, your client. Okay, so it is given as 0.3, 0.6, 0.25, 0.1. This is x value. Okay, then minus 0.7, 0.4, minus 0.4, minus 0.2. Then this one is 0.60, 0.6, 0.2. Okay, 0, 0, 0, 1. This is the spatial manipulator. That is why you have values x. This is x, this is y, z. Okay, this is known to you. From this, you have to find out the value. So the joint values are theta 1, you have to find theta 2 and theta. So you have to find out the formula for this. Okay. So now let's compare this. If you compare this, then it will be easily, you can easily get theta 1. So theta 1 is, so here, yeah, you can take this, or you can take the ratio. So if you take the ratio S2, S3, this will be cancelled. So you will get this, or you can take the ratio of this, and then here you can take the ratio of this. Okay. So these are the various methods. I'm going to use this one. You can use these methods as well. Okay. So what is theta 1? Of tan 2 of, okay. So if you take these two terms, so here what are those terms? Minus 0.2, comma 0.1. Okay, so take the calculator, take the tan inverse of 0.2 minus 0.2 and 0.1, you will get the answer is minus 63.43 degrees. Okay, theta 1 is done. Then theta 2 is, so from this, here we can compare this theta 2. So here theta 2 is this one and this one. Okay, what are those parameters? This. So let's say directly theta 2 equal to of tan 2 of S2, S2 is 0.6, comma 0.6. So we know that this angle is 45 degrees. Okay, so we found it. Then finally we have to find D2. So how will you find D2? Sorry, D3. So either you can apply cos theta 2 and find out D3, or the simple way is you have to square these terms. Okay. So here, if you square these terms, in the next slide I'll show you. So if you square these terms, so it is S1 square S2 square D3 square plus C1 square S2 square and D3 square. Okay. So in this, take the common terms out. Common terms are S2 square, D3 square, and then this will be 1. Okay. So then if you take the square root means it will be S2 D3. If you take square root of this. Okay. Then already you have C2 D3. Okay. So you have C2 D3 in the this term is or 3, 4. Okay, so now how will you get D3? So so this S2 and D3. So here you can take the ratio of these two. Okay, so your D3 equal to zero point 0.2, which is given already, and then your S2 D3 is 0.395. Okay, so this so it is zero point 0.2 divided by cos 45. Okay, because 45 is your theta to degree. Okay, so if you apply this, so you will get 0.282. So in this way, you have to find theta 1, theta 2, and d3 based on the formulas. Okay, so how will you? So just a recap of inverse kinematics. So what is inverse kinematics? So inverse kinematics means if x, y, z, which means Cartesian coordinates. If Cartesian coordinates are given, then inverse kinematics gives you the formula to calculate joint coordinates in serial manipulator. So in serial manipulator, the joints are prismatic. The variable is d, we used to say, and revolute. It is theta. Okay. So if x, y, z are given, that will be used to find theta or d. So this is called as inverse kinematics. So in this, there are three methods we have seen. One is algebraic and geometric. So these can be applicable only for 2DOF. Otherwise, when it's tedious for 2DOF only, it is simpler. Okay. And next one is numericals. We did not follow this numerical methods. Okay, but for small, I mean 2R means we can use geometric method. Okay, but algebraic method can be applicable for all. So we have discussed RPY or RRR, or even if it is 6R also. So the simple logic is how do you apply algebraic method is first get forward kinematics. Okay, and then get goal matrix or desired matrix. Then compare these two. Okay, always collect the terms like sine and cos. Sine 1 cos 1 means theta 1. Sine 2 cos 2 is theta 2. So always collect the terms like this. Okay, and take theta 1 equal to arc tan 2 of sine comma cos. This is the format. Okay, so in a calculator you apply tan inverse of sine by cos. Tan inverse of sine by cos will give you the degree. So this is how we have to perform. So that's all about inverse kinematics. Thanks for watching.